Welcome to this explainer, where we're going to unpack one of the most highly influential frameworks in the entire history of psychology. Today, we're looking at Jean Piaget and the architecture of cognitive development. If you've ever wondered, exactly how children learn, think, and construct their reality right from the ground up, well, you are definitely in the right place. Let's kick things off by throwing out an incredibly old, outdated idea. For the longest time, people just thought of kids as these empty vessels, right? Like blank slates, just waiting around to be filled with facts by adults. But Piaget completely flipped the script. He brilliantly saw children as active little scientists. They aren't just sitting there passively absorbing the world. No, they are out in the field conducting their own messy, hands-on research to actively construct their understanding of reality.
And this brings us to a really fascinating central question. It's one that's absolutely vital for educators, psychology students, and honestly anyone who has ever interacted with a toddler. How does that complex mental architecture actually get constructed from scratch? Like, how do we go from a newborn who basically only knows how to cry and eat to a teenager capable of complex, abstract algebraic reasoning?
To answer that, here's our roadmap for today. First, we'll examine the foundational building blocks of thought. Then, we'll travel chronologically through the early cognitive stages, followed by the advanced logical stages. After that, we'll explore the real-world educational implications, and finally, we'll round out our understanding by looking at some key criticisms of the theory. Okay, let's start right at the foundation with Section 1, Building Blocks, the foundation of thought. Because before a child can navigate the world, they need a system to organize it all. A completely crucial concept to grasp right off the bat is the schema. You can think of a schema as a mental filing cabinet or like little packets of information. Every single time a child encounters something new, they need a folder to put it in so they can actually understand it. These schemas act as the basic structural building blocks for literally all intelligent behavior.
But the world is constantly throwing new things at us, right? So the child has to constantly update these schemas through a three-step adaptation process. Let's say a child has a schema for a kitty, a small four-legged animal. Step 1 is assimilation. They see a small four-legged dog, they fit that new information into their existing schema, point, and proudly say, kitty. But wait, the dog barks, it acts differently. That brings us to step 2, accommodation. The child modifies their mental framework, realizing that old folder just doesn't work here, and creates a brand new schema specifically for dog. Finally, they reach step 3, which is equilibration. The world makes sense again, and they've achieved mental balance.
So the really important takeaway here is that learning actually happens in a state of disequilibrium. That's that exact moment of confusion when the new data, like our barking kitty, just doesn't fit into the mental filing cabinet. It turns out that temporary frustration and confusion, that is the essential driving force behind all cognitive growth. We literally have to lose our balance in order to step forward.
Armed with these structural tools, our little scientist now embarks on their fieldwork. Let's move to Section 2, Early Cognitive Stages, spanning from birth to age 7.
Piaget argued that we all follow this invariant, universal roadmap. We progress chronologically through 4 distinct eras of cognitive ability, starting with the sensorimotor stage at birth, moving through the pre-operational and concrete operational stages, all the way to the formal operational stage in adolescence. And you cannot skip a step. Each one builds the absolute necessary foundation for the next.
Let's zoom in on that very first stage, the sensory motor stage, which goes from birth to about 2 years old. Here, the child understands the world purely through sensory experiences, seeing, hearing, and motor actions like grasping or sucking. But the absolute biggest milestone here is object permanence. This usually develops around 8 or 9 months, and it's the realization that things still exist even when you can't see them. This is exactly why the simple game of peekaboo completely blows an infant's mind. To a young baby, when you cover your face, you literally cease to exist in their universe. When you uncover it, boom, you've performed magic.
As the child grows, they cross into the pre-operational stage, covering ages 2 to 7. During this window, language development absolutely explodes. They start using symbols and images to represent objects, which leads to this wonderful, imaginative, symbolic play. However, true logical thinking just isn't quite there yet. Because they lack that logic, their thinking is defined by some fascinating cognitive quirks that we really need to understand. 2 major concepts that pop up constantly in this stage are egocentrism and animism. Now, egocentrism doesn't mean the child is selfish. It's just a cognitive limitation. It's the sheer inability to see a situation from another person's point of view. The child assumes you see, hear, and feel exactly what they do. Then you have animism, where the child breathes life into the inanimate world. To them, the sun is actually smiling, or their teddy bear has real feelings and intentions and, might actually be sad if it's left on the floor.
Let's see how this builds, because another massive quirk in the preoperational stage is irreversibility. A young child might know that 2 + 3 = 5, but their brain gets stuck in that one direction of thought. They fail to mentally reverse the sequence to realize that 5 - 3 = 2. This perfectly contrasts with the reversibility they will eventually unlock, because once they can mentally rewind an action, they are finally ready to level up to the next developmental era.
Which brings us right to Section 3, Advanced Logical Stages, covering ages 7 into adulthood. As our little scientist grows, their cognitive toolkit gets a massive logical upgrade, paving the way for advanced problem solving. Entering the concrete operational stage, the holy grail of cognitive milestones is achieved: conservation. This is the understanding that altering the appearance of something doesn't actually change its fundamental properties. The classic test is pouring water from a short, wide glass into a tall, thin glass. A pre-operational child will absolutely swear the tall glass has more water, but the concrete operational child, they'll just smile and tell you it's the exact same amount of water because they finally grasp that volume remains identical despite the container's shape.
So during this concrete operational stage, from about age 7 to 11, we see the real beginning of true logical and operational thought. They master conservation, they master reversibility, and they develop these fantastic abilities to sort objects through seriation and classification. But, and this is a huge but, it's vital to remember that their powerful new logic is strictly tied to physical, concrete objects they can actually see and touch. If you ask them to solve a logic puzzle about the wooden blocks right in front of them, they are absolute geniuses. But ask them to solve a logic puzzle in their head about abstract concepts, they're going to hit a wall.
It's not until they hit the final developmental milestone, the formal operational stage at age 11 and beyond, that thought liberates itself from the physical world. Now they can handle purely abstract concepts. They develop hypothetico-deductive reasoning, which is just a fancy way of saying the ability to ask what-if scenarios and formulate systematic plans to find a solution. With the emergence of combinatorial thought, where they can juggle multiple variables all at once, our little scientist is finally thinking and problem-solving just like an adult scientist.
So, we've got this beautifully structured map of the mind. But how do we actually apply it in the real world? Let's look at Section 4, Educational Implications and Teaching Methods.
Piaget's architecture lays down a pretty strict set of rules for educators. First up is discovery learning. Because children are active builders of knowledge, rote memorization is totally discouraged. They need to learn by doing, by exploring. Second is the principle of readiness. You simply cannot introduce concepts before a child's brain is developmentally prepared. Forcing abstract algebra onto a 7-year-old completely violates their natural cognitive stage. They just don't have the schemas for it yet. And lastly, while the sequence of stages is universal, the pace is not. Educators really must adapt instruction to honor individual differences in how fast children progress.
Piaget completely changed how we view childhood, but, every good scientific theory requires rigorous peer review. That brings us to Section 5, Criticisms and the Limits of the Theory.
These limitations are actually heavily debated in modern psychology. First off, Piaget heavily underestimated infant capabilities. Modern research using eye-tracking technology shows that infants actually grasp concepts like object permanence much earlier than Piaget originally claimed. Plus, critics point out the rigidity of his stages. Today, we know that human development is much more continuous and fluid rather than operating in these strict compartmentalized jumps. But perhaps the biggest criticism of all is his near-total neglect of community and culture.
This debate represents a true clash of titans in developmental psychology. Piaget focused almost exclusively on individual discovery. He basically envisioned the child as a lone scientist in a vacuum, driven entirely by natural biological architecture. In contrast, critics like Lev Vygotsky argued that Piaget entirely missed the forest for the trees. Vygotsky believed that social interaction, language, and cultural context are actually the primary drivers of cognitive growth. A child doesn't just learn by playing with blocks alone, they learn because a parent, a teacher, or a peer is sitting right next to them, guiding their understanding.
Piaget gave us an incredible blueprint of the mind, fundamentally transforming our respect for exactly how children construct their reality. But looking at the modern research, it leaves us with a pretty compelling question to chew on. While schemas and adaptation are undoubtedly real,
Can the messy, continuous, and highly social reality of human growth ever truly be put into 4 neat little boxes? It's definitely something to consider the next time you watch a child figure out a new game. Thanks for joining me on this explainer, and keep exploring.